Hey everyone, and welcome. Today, we're going to peel back the layers of software design and look at the very blueprints that hold everything together, architectural patterns. Let's dive right in. You know how it is. Use an app, you tap a button, and poof, magic happens. But have you ever stopped to wonder how it's all structured underneath? How do developers build these massive, complex systems without them just collapsing into a tangled mess? Well, the answer is all about something called software architecture.
So what is it really? Think of it like the foundation and the steel frame of a skyscraper. It defines the big core pieces of a system and, crucially, how they all connect. These are the major decisions you make right at the start, and they are incredibly difficult, sometimes impossible to change later. You get the architecture right, you're building on solid ground. You get it wrong, and, well, the whole thing could be dangerously unstable.
Now, to even talk about architecture, we use a really simple visual language. We draw the main components as black boxes. We don't need to know the messy details inside, we just need to know what they do. Then we connect them with lines, or what we call conduits, which just show how they talk to each other and pass information back and forth. It's like a high-level map of the entire system.
Okay, our first pattern is a perfect example of this idea in action. I like to think of it as a data assembly line. It's called the pipe and filter pattern, and it is absolutely brilliant for processing streams of data.
So, imagine you've got a ton of raw data, and you need to clean it, sort it, and transform it through several different stages. How would you design a system where each of those stages is its own separate, reusable tool, and they all work together in this perfect, orderly sequence?
A classic example of this is a program that finds all the anagrams in a dictionary file. Here's how it works. First, a program called Sign takes each word and creates a signature for it by sorting its letters. So silent and listen both become ILNST. The output of that program is then piped, which literally means it becomes the input for the next program, a standard sort utility. This groups all those identical signatures together. And finally, that sorted list gets piped to one last program, Squash, which just cleans it all up, putting each set of anagrams on a single line. See? 3 separate steps, one clean, logical flow of data.
So the magic here is that these components, the filters, are totally independent. They just take data in and spit transformed data out. The pipes are just the plumbing that connects them. The real power? Composability. You can mix and match these filters in all sorts of new ways to create totally new data pipelines. The classic example of this, as we just saw, is the Unix command line. It's a masterclass in this style. The one catch is that this pattern isn't really built for interactive systems, because the data pretty much just flows in one direction.
All right, so what if you're not just processing a stream of data, but you're building an interactive application that a person has to use? For that, we turn to one of the most famous patterns in all of software development, the Model View Controller, or MVC. The best way to think of it is as a highly specialized team of 3, where each member has one very specific job.
Now, to get why MVC is so important, you first have to understand the problem it was designed to solve. Back in the early days of graphical interfaces, all the code got mushed together. The code for drawing the buttons on the screen was mixed in with the code for handling mouse clicks, which was tangled up with the code for the actual application data. It was an absolute nightmare to manage. The solution was this really powerful idea: separation of concerns. What if we could just split those jobs up?
And that's exactly what MVC does. First, you have the model. It's the brains of the operation. It manages all the application's data and all the business logic. It has zero idea what the user interface looks like. Then you have the view. The view is the pretty face. Its only job is to present the data from the model to the user. Finally, you have the controller. It's kind of like the traffic cop. It listens for user inputs, like clicks and keystrokes, and then it tells the model and the view what they need to do. It's a powerful setup, though for really simple apps, it can sometimes feel like a bit of overkill.
So let's walk through a quick example. You, the user, click a button on the screen. That's the view. The controller is the one that actually catches that click event. It then turns to the model and says, hey, the user wants to add this item to their cart. The model updates its internal data. The view, which is always keeping an eye on the model, sees that change and automatically redraws the screen to show the updated shopping cart. It's clean, it's organized, and it's so much easier to maintain. Okay, our third pattern is literally everywhere. In fact, you are using it right this second to watch this. It's the client-server pattern. And the absolute best way to picture this is a service counter at a busy restaurant.
The whole idea is to divide up the labor. On one side, you have the client. That's what you interact with, your web browser, your mobile app. Its job is to handle the user interface and make requests. On the other side of the counter, you have the server. This is a powerful machine somewhere else that does all the heavy lifting. It stores the data, it runs the complex calculations, and it provides services back to the client whenever it's asked. It's a super efficient setup, but it does mean that if the server ever goes down, your client might be totally useless.
This pattern is the literal backbone of the modern internet. Your browser is a client, and it's asking a web server for a web page. When you go to print a document, your word processor acts as a client, sending a job request to your computer's print service, which is the server. Even graphical interfaces on operating systems like Linux use this model. Individual programs are clients that ask a central X server to please draw their windows on the screen.
Okay, so we've just covered 3 absolutely fundamental architectural patterns. Each one is a specific tool for a specific job. So let's do a quick recap so you know which tool to reach for and when.
Let's just boil it all down. You should reach for pipe and filter when you have that clean, sequential data assembly line. Go with Model View Controller, or MVC, anytime you're building an app with a user interface and you need to keep your data and presentation logic separate. And finally, use the client-server pattern when you're building a distributed system and you need to split the work between the thing the user sees and a powerful backend.
And that's our quick tour of 3 foundational software architectural patterns. If this helped you connect some of the dots, do me a favor and hit that like button, share it with a friend, and definitely subscribe for more deep dives into complex topics just like this one.
So I'll leave you with this one final thought. The next time you're browsing the web, or playing a game, or just using any app on your phone, take a second and think. Can you see the architecture humming away underneath it all? Which of these patterns is at work, quietly making everything possible? Thanks so much for watching,